Hey, how's it going, guys? So we're going to be going over this question here. A cat leaps to try and catch a bird. If the cat's jump is 60 degrees off the ground and its initial velocity was 2.74 meters a second, what is the highest point of its trajectory, neglecting air resistance? Well, this question actually gives you quite a lot. And the first step in order to know how to solve it is knowing what we're given. We're giving theta, which is 60 degrees, and we know it's respect to x because it's off the ground, and we're giving our initial velocity, which is our v naught, and it's just going to be 2.74 meters a second. It's always important to write our units just so we don't forget. Let's go ahead and actually solve for this and figure out how we're going to do it. Well, if you know projectile motion and you know the formulas right off your top of your head, you should know that v squared, v naught squared, times sine squared of theta over 2g should give you what we're looking for, which is apogee. Now, if you know that, this is literally just plug and play, and you'll get your answer. Let's say you don't know that. Let's say that you don't, or let's say you do know that formula, but you don't know when to use it, or why we use it, and how we got it. Well, that formula originates from our kinematic formulas. And we know that we have two formulas that would help us find what we're looking for, which is the change in y, which is the displacement formula, and that one's just equal to v naught times t, well, v naught of y times t minus 1/2 times g time squared. And we also have our kinematic formula for velocity for y. Oh, it's an ugly y. Which should be v naught of y minus g of t. And again, if you're confused as to how we get that, it's really just the derivative of this formula. So, let's go ahead and use these formulas to find what we want. Well, we're looking for when the change in y is at its max height. So what we can do is solve for t so we can plug it into this formula. So what we're going to do is we're going to solve for t using this formula. And we're going to go ahead, and when you simplify this, because we're going to add g of t to both sides, you're going to go ahead, and then you're going to go ahead and divide that g. You're really just going to go ahead and get v naught of y over g equals t. When you are giving another piece of information, remember how I was talking about how this is off the ground? Well, that's really important because when we work with, horizontal and vertical directions, we know they're independent of each other in physics. For this example, anyways. And one of the things that we know is that when you're working with an angle that's adjacent, you would use cosine. However, if you're trying to get, an answer with respect to the y, and the angle is not adjacent to that because it's against it, you would use sine. So we know that v naught really equals sine theta of v naught. Or let's write that a different way because that's kind of an ugly way of writing that. We know that v naught is equal to v naught times sine of theta. So with that, we can also go ahead and further define time as v naught times sine theta. And would you look at that? We can go ahead and take this and plug it into that formula. So let's go ahead and erase our lower half here because we no longer need it. And I'm just going to go ahead and memorize it. T equals v naught sine theta over g. And we're going to go ahead and get v naught y sine theta. Because remember, we know that we're working in sine, and our v naught really just equals v naught times sine theta times v naught sine theta over g. Remember, that's what t equals. We have a t there. Minus 1/2. These are just variables. We know that g, well, for now I'm just going to leave it as g so we can simplify this equation. We also know that t is v naught y sine theta. Again, we have another t over g squared. Again, we have another t. Now, when you simplify, and just for the sake of time, I won't get much into it, but when you simplify this formula, you should get v naught y squared times sine squared theta over 2 of g. And there you go. That was the formula we were originally going to use, and that is how we were going. This is why we were going to use that formula. So, with that formula now declared, it's literally just a matter of plugging and playing. We know we're using 60 for theta, 2.74 meters a second, and we also know that little g equals the Earth's gravity, which is 9.8, an acceleration of 9.81 meters per second, which we can plug into here, which would give us 2.74 squared times sine squared of 60 degrees divided by 2 times 9.81. When we go ahead and go ahead and do this problem, you should get about 0.28 meters a second. And there you go. That's your answer.